Good morning. I welcome you all to the series of lectures on thermodynamics. Today we are going to discuss about the second law of thermodynamics. Basically, second law of thermodynamics consists of two statements: Kelvin Planck statement and Clausius statement. First, to define the or discuss about the Kelvin Planck statement. This is the heat engine. This is the representation of the heat engine. Source T1, sink T2, and heat Q1, Q2 amount of heat is rejecting. So it is taking heat from high temperature reservoir, that is Q1, part of which is converted as work, that is W net, which is nothing but Q1 minus Q2, and part of which is part of heat, that is Q1, is rejected as heat Q2 to the low temperature reservoir, that is called sink T2. So the condition is T1 is all the time more than T2. Now efficiency equal to W net equal to net work done by efficiency equal to W net by heat supplied. W net is the net work done by heat supplied. So efficiency equal to W net by heat supplied is Q1. So W net by Q1, that is equal to Q1 minus Q. W net is Q1 minus Q2 by Q1. Then efficiency equal to 1 minus Q2 by Q1. So if you observe this one, see Q1 is all the time more than W net by an amount of Q2. So that means W net is all the time less than Q1. See, that is the statement. W net is all the time less than Q1, since heat Q1 transferred to a system cannot be completely converted into work in a cycle, and efficiency is less than unity. So that means heat is not completely converted into work. Some amount of heat is rejecting to the low temperature reservoir. So then what is the statement? If heat is converted 100% converted into work, the efficiency is 100%. That means if Q2 is 0, if I put Q2 is equal to 0, then W is equal to Q1, then see Q2, if Q2 is 0, 0 by something 0, 1 minus 0, 1, the efficiency equal to 1. Otherwise, if Q2 is 0, W net equal to Q1, so W net equal to Q1, so it is equal to 1, efficiency is equal to 1, that means 100%. So but it is not practically, no, because heat never converted into 100% converted into work. So there must be some heat rejection all the time. Q2 must be present. So if Q2 is there, if Q2 is not there, there is no need to provide this reservoir. If Q2 is there, we must have a reservoir, sink reservoir. That means we must have two reservoirs. That is the Kelvin statement. Let us discuss the Kelvin statement. The Kelvin Planck statement of second law states it is impossible for a heat engine to produce net work in a complete cycle if it is exchanges heat with only one reservoir. It is not at all possible to exchange heat with one reservoir. If it is exchanging with one reservoir, Q2 is 0. Q2 is 0 means 100% efficiency. So Kelvin Planck statement gives 100% efficiency of engine can never exist. That is the statement simply. That means indirectly he clearly mentioned there must be two reservoirs to exchange heat or to convert heat into work. There must be two reservoirs. That is the statement. If Q2 is 0, what happens? See, if Q2 is 0, that is W net equal to Q1 only. Q2 is 0. W net equal to Q1. Then efficiency equal to W net by Q1. So W net equal to Q1. Q1 by Q1 cancel 100%. The heat engine will produce net work in a complete cycle by exchanging heat with only one reservoir, thus violating the Kelvin Planck statement. Such a heat engine is called perpetual motion machine of second kind. Okay, abbreviated as PMM2. Actually, what is the Kelvin statement? There must be two reservoirs. As far as perpetual motion machine of second kind is considered, there no need to go for second reservoir because Q is directly converted into work, 100% conversion into work, because Q1 W is equal to Q1, so there is no need to go for another reservoir. So it is not possible. So a PMM2 is impossible. PMM2 is impossible because it is violating the Kelvin Planck statement. If any engine or any device violating the Kelvin Planck statement, which is not at all possible, that is the statement of Kelvin statement. Now let us go to the Clausius statement of second law. So it is very simple. If you observe the refrigerator or a heat pump, see, heat always flows from high temperature body to low temperature spontaneously without doing anything. Heat can flows from, so this is T1 is more than T2 here. It can flow from here to here without doing anything. This are also this is source, this is sink, T1 is more than T2, this temperature is more than this one, so heat can flow from high temperature body to low temperature body without doing anything. That means spontaneously it can come, heat can come spontaneously from high temperature reservoir to low temperature reservoir, but the reverse can never occur spontaneously. To achieve this we have to spend some work, okay, we have to spend some energy to the system. Then only the heat can flows from low temperature body to high temperature body. Then only heat flows from low temperature body to high temperature body. That is the statement of the Clausius statement. Clausius statement of the second law gives it is impossible to construct a device which is operating in a cycle will produce no effect other than transfer of heat from cooler body to hotter body. That means it is not possible to transfer heat from low temperature body to high temperature body without doing anything. With doing some work or some energy we can achieve that, that is heat can flows from low temperature body to high temperature body if you supply some amount of energy to the system. That is the Clausius statement of the second law of thermodynamics. Thank you very much.